Lesson 8 we'll review what polynomials are, and then we'll talk about some linear relationships, how to graph linear equations using a couple of different methods. Now polynomials, that's just a name for a certain type of term. It has this form, a x to the n, where a is some integer value, x is a variable, and n is some integer power. And actually the exponent, we don't use negative exponents when we're defining a polynomial, so it would just be whole numbers 0, 1, 2, 3 and on. The coefficient can be an integer though. For example, this is a polynomial, an example of a polynomial 4. Because x to the 0 is equal to just 1, we could write it 4x to the 0, but normally we just write it 4. So when you see just a constant like that, it really is a polynomial. Within polynomials we have combinations when we add different polynomials together. For example, just one by itself would be called a monomial, and then we could call this a binomial. This, we might call that a trinomial, or we would call that a trinomial. Then that last one, if we add an equal sign and a value on the right side, we'd call that a polynomial equation. Now that would be called a polynomial equation in one unknown. This would be a polynomial equation in two unknowns. And it would be considered a first degree polynomial because the highest power that you see there is 1, y to the 1, x to the 1. The equation above it, we would call that a second degree polynomial because the highest power that you see is a 2, x squared. Now why are we talking about a first degree polynomial in two unknowns? Well, that is what the equation of a line is. If you graphed that equation, you can graph that on an xy axis or a Cartesian coordinate system, same thing. You can get the equation of a line. Now if you remember, there's a standard form for an equation of a line, y equals mx plus b. M is called the slope, b is called the y-intercept. Before we get into the slope and y-intercept and what those mean, let's just review graphing a linear equation. Look at practice problem A, y equals 1/2 x minus 3. Let's graph that on an xy axis. So the first thing that we have to do is we have to find combinations or xy pairs that satisfy that equation. Those are our ordered pairs or points that we can plot on an xy graph. Then we connect those points together with a line, and that shows the path of that line. So the first thing that we do is we make an xy table. And what we do is just pick some convenient values for x to substitute into that equation and solve for y, and that will give us our xy pairs or points. And let's use some values that will cancel that half fraction out. So let's use a -2, a 0, and a 2. And I'm just using those because it's easier to work with numbers that are not fractions than it is to work with fractional numbers. So if I put a -2 into that equation, I'd have y equals 1/2 times 2, or times -2 minus 3, which would give me -1 minus 3 is -4. Then I would have y equals 1/2 times 0 is 0 minus 3, which would be just a -3. Then y equals 1/2 times 2, which is just 1 minus 3 is a -2. So now I have those three ordered pairs. A line is defined by 2 points at least. We have 3 points, so we know we can find out where this line is. Let's make an xy coordinate system. We'll try to make our tick marks as evenly spaced as possible. If you want to, for these problems, you can get some graph paper out and use graph paper, because there you already have your tick marks made for you. Now let's go ahead and locate those points on this xy axis. And remember, the horizontal axis, that's considered our x-axis. The vertical axis is considered the y-axis. Where they intersect, that's considered 0 for both of them. And so the x-axis To the right of that intersection is positive values. To the left is negative. The y-axis above it is positive. Below the intersection are negative numbers. And so our first ordered pair is -2, -4. And so that would mean that we would start at 0. You always start at the origin, and we would move to the left 2 and then down 4 and put a point right there. Now normally we don't draw those lines on there. I'm just doing that so that you can see the path that I took to get to that point. The left 2 and down 4. And so I'll try to erase that line there so it's not in our way anymore. Then the next point would be 0 and -3. So that means we don't move to the left or the right in the x direction. We just start at 0 and go down 3 and put a point right there. And then the next point is 2 and -2. So that one we go to the right 2 and down 2, and hopefully you know that that means the point would be right there. Now do you see the pattern that those points have? They have the pattern of a line, and so we can just draw a line right through those, and that's the representation of y equals 1/2 x minus 3 on an xy graph. So that's one of the really interesting things about a line like that, about a polynomial equation in two unknowns that's first degree. The pairs of xy values, which are called ordered pairs, that satisfy that equation, meaning it makes the left side equal to the right side, those can be plotted on an xy axis and they form a linear pattern. We know that a line, it has no ends. It continues on in both directions forever and ever. And there are an infinite number of xy pairs that would satisfy that equation. So that's what we would expect. Since a line has infinite boundaries, there's an infinite set of ordered pairs that would satisfy that equation for a line. Now there's another way we could have graphed that same equation, and that's called the slope-intercept method. If you understand the components of the standard linear equation, the y equals mx plus b, you can just do that. Use the slope-intercept method instead of setting up an xy table to graph a linear equation. Now the first thing to understand in that standard form, let's just rewrite it down here, y equals mx plus b. The first thing to understand is b, and that's called the y-intercept. That is where the line crosses the y-axis. That constant value that at the end, y equals mx plus b, that b value, that is where it crosses the y-axis. And you can see that in the problem we just did. Y equals 1/2 x minus 3. The y-intercept is -3. And see, that line crosses the y-axis at -3. M is the slope. And that tells you basically how steep the slope is. If you look at the problem from left to right, or look at the graph from left to right, the slope can be positive or negative. It's positive if it goes uphill from left to right, and you can always tell also because the coefficient of x, the m value, is a positive number. If that's a negative number, then the slope goes downhill from left to right. And one thing that does is that helps you know if you did the graph right. For example, if our problem A would have been y equals -1/2 x, we would have had a slope going downhill from left to right. But it's positive 1/2 x, so it's going uphill. That helps us know we're doing the right thing. And the slope is a fraction. It's the ratio of the change in the y direction to the change in the x direction. So look at that graph that I've just drawn, and let's just start at the y-intercept. And our slope is 1/2, so that means our change in y is 1 and our change in x is 2. So that means every time we move 1 in the y direction, we move 2 in the x direction. So I'm going to use a blue line, and I'll start at the y-intercept and go up 1, because every time we change positive y, and then we'll go to the right 2, and see, we hit the line again. We could go up and to the right 2 again, and we would hit the line again. And you just keep doing that over and over. Now it could also be -1 over -2, because that also equals 1/2 x. So from the y-intercept we could go down 1 and over 2, down 1 and over 2. And see, you hit the line again. Down 1 and over 2. Therefore, if you understand what slope means and then you know what the y-intercept is, you can just use those two properties of the equation of a line to graph a line. Look at practice problem B. Let's use the slope-intercept method to graph that equation of a line. And so let's just go ahead and make an xy axis, or Cartesian coordinate system, it's also called that. Okay, now we start at the y-intercept. That would be a positive 2. And so I'll put a dot at positive 2. Our slope is negative 1/3. So let's just think about that. Remember, slope, I'll say m, that's equal to the change in y over the change in x. And so if it's negative 1/3, that means negative 1 over 3, or 1, positive 1 over negative 3. It doesn't matter which one you make negative. When the whole number is negative, you can have a negative numerator or denominator. We'll have a negative numerator for these problems. And so we'll do negative 1 over 3. And so from the y-intercept, that means we'll go down 1, that's our change in y, and then to the right 3. That's our change in x, a positive 3. So down 1 and to the right 3 would put a point right there. Down 1 and to the right 3 again would put a point right there. We can go back to the y-intercept and go the other way, up 1 and to the left 3, and that would put a point right here. And you can see the linear pattern that is developed. Let's do one more. Practice problem C. 2x plus 5y equals 10. Now that may not look like an equation of a line to you, but we see that it's a first degree polynomial in two unknowns. So what we need to do is get it in standard form. Y equals mx plus b. And so we can do that by moving the x over to the right side. So we would have 5y equals negative 2x plus 10. And then we divide every term by 5. And so that means this, this, and this. Every term gets divided by 5. Y equals negative 2/5 times x plus 10 over 5, which is just 2. Now we can go ahead and set up an xy coordinate system. Okay, and so now let's plot our points, and we start with our y-intercept. It's equal to 2, so we put a point right there. Our slope is negative 2/5, so that means we would go down 2 and to the right 1, 2, 3, 4, 5 and put a point. Now we could also go from the y-intercept, we could go up 2 and to the left 1, 2, 3, 4, 5 and put a point right there. We see the linear pattern formed by those points, and so we draw a line right through those. And just think about it, does that graph make sense? We have a slope going downhill from left to right. Well, we had a negative value for m, or our slope. It was negative 2/5, so that does make sense that it goes downhill from left to right. Now, a lot of patterns in nature are linear patterns. Scientists use linear equations a lot to help them understand different relationships between a pair of values. So make sure you remember what slope means. Look what I'm highlighting over here on the left. Slope is delta y over delta x, the change in y over the change in x. Y-intercept, that's pretty easy. It's just where the line crosses the y-axis. And when you get it in the standard form, y equals mx plus b, it's just that constant value at the end, b. That's always where the line crosses the y-axis. Then, as long as the line's in standard form, m, that's the slope, the change in y over the change in x. If it's a whole number like a 5 or something, just turn it into 5 over 1. Make it look like a fraction. Okay, well that's all for lesson 8.